All right, let's get right into it. We're constantly hearing about how incredibly powerful the latest AI models are getting. But you know what? A brand new benchmark just found a pretty shocking blind spot, a single riddle that stumps every single one of them. So today, we're going to dig into what that riddle is and what it tells us about what true machine intelligence really looks like. So what is it? What's this one question that can stop the world's most advanced artificial minds dead in their tracks? I'm about to show you the exact riddle. See if you can solve it before we get to why the AIs just can't. So, there it is. A blue ball thrown 1 meter up, a purple ball thrown 2 meters up. And then all this other stuff happens with a ladder and a balloon. So where is the purple ball? Have a think about it for a second. Now, what do the AIs say? Well, just look at this. This is why this whole thing is so fascinating. These are the results from a new test called the GIAGo benchmark, which was built specifically to find these little cracks in AI reasoning. See that row for the juggling riddle? It is just a sea of red fail marks. Every single model gets it wrong. This isn't just a fluke, you guys. It's a symptom of something much, much deeper. Right, so why does this happen? To really get it, we need to look at how we even test AIs in the first place. The problem is, a lot of the current tests can be aced by models that are just really, really good at memorizing stuff, not actually reasoning their way through a problem. And this creates something researchers are calling the recall illusion. See, at their heart, these AIs are unbelievably sophisticated pattern matching machines. They've read basically the whole internet, and they're just predicting the next most likely word in a sentence. It can look a whole lot like understanding, but it isn't really. It's kind of like a student who memorizes an entire textbook word for word, but can't solve a single problem that isn't printed right there on the page. And that is exactly where the GIAGo benchmark comes in. It's designed to cut right through that illusion. You can think of it as a cognitive gauntlet, built to test for the real deal, things like learning, attention, executive function, by throwing scenarios at the AI that it has definitely never seen before. So, how does this thing actually work? How does it manage to trick these incredibly powerful systems? Well, the method is actually brilliantly simple. It goes after the core building blocks of reasoning itself. Okay, this is where it gets really clever. The test isn't just about finding the right answer. It's about seeing how the AI gets there. For example, it uses red herrings. Sound familiar? Think about the ladder and the balloon in our juggling riddle. That's a classic test of attention. Can the AI focus on what's important and filter out all the useless noise? That's a key executive function that our brains do constantly without even thinking about it. And the test really breaks down into two main categories. On one hand, you have these physical riddles that check if the model has a basic grasp of reality. How objects move, how things change. And on the other hand, you have social cognition tests. These try to figure out if the AI can understand the messy, complicated web of human emotions and motivations. Let's look at a quick example of each. So here's a physical one. The key here isn't just counting to 4. The AI has to actually simulate a physical process in its head. Ice cubes on a hot frying pan. Well, they're going to melt. The question specifically asks for whole ice cubes, so the answer, of course, is 0. This needs a common sense model of the world, not just being good at math. And then you have this one, a social test. Jen tells John about a diet, a dog, a nuclear war, and that she cheated on him. Now, an AI might just logically pick nuclear war as the biggest deal, but a human understands relationships. We know that for John, the personal betrayal is almost certainly what's most devastating. The AI has to try and infer human priorities, which is incredibly difficult. Okay, so we've seen how the test is designed to trick these AIs. Now for the fun part, the results. Let's look at the leaderboard, because it has some real surprises. What you see is the models sort of clustering into these clear performance groups. You've got your elite performers up top, scoring over 90%. Then there's a solid block of what we can call mid-tier reasoners. And then way down at the bottom, you have the more experimental or niche models that, frankly, really struggle with this kind of test. And who's sitting at the absolute top of the class? Well, it's actually a tie. Both Claude 4.5 Sonnet and Gemini 3.1 Pro Preview hit this peak score. They managed to correctly answer 10 out of the 11 challenges, but what's really fascinating is what happens just below them. Now this, to me, is one of the most interesting takeaways from the whole thing. The newer and actually smaller model, Gemini 3 Flash, does better than its larger predecessor, Gemini 2.5 Pro. This suggests that when it comes to true reasoning, just making the model bigger isn't the whole story. It seems like improvements in the architecture and the quality of the training data might be even more important. It's about being smarter, not just bigger. All right, let's bring it all home. It's time to circle back to where we started and finally solve the mystery of the juggling riddle. Let's break down the exact cognitive failures that lead to that wall of red fail scores. So here it is again. The blue ball goes up 1 meter, the purple ball goes up 2. The juggler, the ladder, the yellow balloon, we know now that those are all just noise. They're distractions. So what is actually going on inside the AI's mind when it reads this? It really comes down to these 3 core failures. First off, the AI can't run a continuous physical simulation. It just struggles to model gravity and the paths of 2 different objects at the same time. Second, its attention mechanism breaks down. It gets completely distracted by the noise, all those irrelevant details a human brain just filters out automatically. And finally, it lacks the basic common sense reasoning to prioritize the laws of physics over the little story it's being told.
So what's the big picture here? What does all this mean for the future of AI? Well, this clever new test points directly at the next major hurdle in the quest for anything resembling true artificial general intelligence. And that hurdle has a name: System 2 reasoning. It's basically the difference between a gut reaction, pattern-matching response, and the ability to deliberately stop, think, and build a mental model of a situation. It's what you do when you're working through a tough problem, and it's exactly what these AIs are still really bad at.
Ultimately, what the GIAGo benchmark really shows us is this. AIs are becoming absolutely incredible masters of language. I mean, they can write, they can summarize, they can translate with a fluency that is just stunning. But, and it's a big but, they still have a really hard time understanding and modeling our physical and social reality. And that leaves us with the big question, doesn't it? They have managed to crack the code of human language. But the next, and frankly much harder step, is cracking the code of human reality. And that is the frontier that tests like this are just now beginning to let us explore.